be better depending on the example, or a lower number. Here, for example, the suicide rate, lower is better. So that would be like first place would be a lower score. But like a score for a test, higher is better. So we rate these based on which is considered like best.
Would it be in the question? Kind of like
it'll be in the question, kind of. Like I might not give it completely away, but here I'm trying to get like another example.
Like if you were to do it above Texas, you wanted to find the one above.
I'm sorry.
You wouldn't be able to do it the same if you were to add it down below Texas, maybe above. So like above Texas. Like above, like if you wanted to know below, but if you did above, and that were higher, then it would be higher, and then it would be registered as super.
Yeah. The thing with percentile rates, they always look for the positive. How did you score better than other people? So you always want to form your equation that way versus the opposite. Like how many people did worse than you? You're looking at how many people scored below you.
Yeah.
Okay. Not the other way around. Okay.
Oh, that's right.
How many people scored below you? Let's do another one. This time with Alaska.
Question in the back.
Yes.
For example, like Wyoming is the lowest one, right? You say, okay, what's below 131?
Wyoming is the lowest. Right, so there's nothing below it, right? So it'd be 100, like
88%.
right, you did 100% better. It's interesting because normally we don't have like 0 as a numerator, right? But here there were like no states that performed worse. So you typically don't say in the 100th percentile. You would say like in the 99.9999 or something percentile. I just have never heard anybody say 100. Usually you won't have like the top scorer. But that's what I would do here. This is a great question. It's a great question.
So what do we do next? Alaska?
Do Alaska. And I'm going to get somebody to come up and explain this kind of like we did, walk them through it. This is how we're talking about it. It's going to matter.
You want to sing the lower?
It's a good question. Talk in your groups. Yeah. What is the percentile rank for Alaska for suicide rates? Yeah.
Not including you, because it's always below you, right?
That's right.
Why?
I'll bring it up again. We'll do that one again. There's always 8.
You're always not included. Technically, it's below you.
That's a good point. I'm going to bring that up again.
Yeah, so it's Alaska, so how many are below? 1, 2, 3, 4, 5, 6.
Maybe just like a decimal point or 2 decimal points.
It's just 7 below that. So that would be the number below, so that would be the top number 7, and you still have your total number, which is 9. So it's 7 over 9, and you get a top 7.
Who still needs time on Alaska? I'm going to have somebody walk through this example for me. Who thinks they can do it?
Is this for extra points?
5 points.
1 point?
All right. Everybody, let's give her your whole attention. She's going to explain it, right? She's going to walk through it, and we'll give her some feedback, okay? So the question was, what is the percentile rank for Alaska? Okay?
So it was 7.
How'd you get 7? What does that number mean?
Because there's 7 below Alaska, right?
Right. So
There's 7 states that fell below.
there's 7 states that
Yeah.
fell below Alaska, so that's how you got your numerator.
Yeah. There was 9 states in total. Times 100 equals, it was 77.7. But I rounded off to 78%.
Or I would keep it 1 decimal point.
Oh.
It doesn't. Yeah, I prefer more like 1, at least 1. So 77.1. Is that what everybody got? So what does that mean for Alaska? Yeah, 77.7 states fell below Alaska on suicide rates. Okay. Now, somebody brought up a good point in the back and right here about Wyoming, right? The numerator is not going to be 0 like this, right? Why? What is the numerator? How do you determine the numerator? So you do how many are below? So they're 8 over 9, right? What is that?
11%.
11? Is that right? I have to look at a calculator.
No, it's the 89%. So
89%?
89%.
Is that right?
Yeah, 0.88. 0.88.
1888888.
Yeah. Okay. So 89%, right? So 89% of the states fall below. This is kind of a little bit inaccurate, right? Especially when we only have 9 states. Like usually when we're talking about percentile ranks, we're going to be dealing with lots of data, right? Like how many people in the country take the SAT or the GRE. That's a lot of people, right? So when I said I've never seen 100%, I've just never seen it. I've seen it 99.99% or something like that, but never 100%. And this is why, is because we're always subtracting at least one thing, right? There's always going to be some people below. Right.
So for this one, California
Yeah,
would be the lowest.
what about California?
California would be the lowest.
Right, okay, I was confused. Yeah, so it is going to be 0. There's 0 below that, over 100.
0 over 9 or that.
So what would that be called? The percentile? There would be
I would say, this is how I would word it, but I've never seen it like this. I would just say there are no scores below this person.
Oh, because they're really in
Right. It has the worst. 0 states fall below California on suicide rates. That's how I would say it. I wouldn't even go about calculating it because you can't really, right? I would just say no states fall below California on suicide rate. It's the worst state. That's what I would say. Yeah, but all the other ones you can go ahead and calculate. This one, the calculation is impossible. Okay. It's a bit confusing. Does everybody feel like they're able to calculate these now? If you have any questions or concerns about calculating percentile ranks. Here is just a thing. I will not test you on the difference between percentile versus percentile rank. So you can write that down that you will not have to know the difference between a percentile and percentile rank because I think that the distinction is not really that necessary. But basically, the percentile rank is the percentage of individuals in the distribution was scored at or below a particular value. So you could say, like, if for Jane, her percentile rank on the exam was in the 60th percentile, meaning 60% of students received a grade lower than Jane. So percentile is just looking at a score, saying that 70% on exam 1 in this class, that score is in the 60th percentile. Okay? When I look and say, how did Jane score? What percentage of people in the class scored below Jane? I would say that Jane's percentile rank was in the 60th percentile. So looking at her in particular, her score. Percentile is just looking at the number, the actual score on the exam. So anybody who got a 70% on the exam is in the 60th percentile.
It's like the equation is the percentile rank.
This is the percentile rank. Yeah.
And then
It asks like what percent of the scores fall below a particular score, percentile rank. So when you're figuring this out, that's what it's going to be. when somebody just says, what is a score of 70%, and you reply that it's in the 60th percentile, it's not like a rank. I'm not talking about an individual person or individual state on the measure. But I'm not going to ask you the difference between the two because I think it's confusing and doesn't really matter. But the book mentioned it, so I thought I would bring it up. All right. Describing distributions. The mean, it shouldn't be too hard, right? Everybody should be on board with the mean. It's the average score. So you total all the scores up and divide by the sum of cases. So quickly come up with a mean for this data set. Scores divided by n. Does anybody need more time on this one? Does anybody need more time? What did you get? 10.6. That's what I got. Did anybody not get 10.6? It's okay. There's time to say it. Everybody got 10.6? For something like this, especially for a test or quiz, I might calculate it twice to make sure I get the same answer both times because it's really easy to make an error in the calculator, right? I would just go slowly. And it's going to matter for some of our other calculations that require a mean. So if you get the incorrect mean, then everything else in your calculations are going to be incorrect. Okay? So what does the mean tell us again? The average score. So if I had exam 1, I get everybody's score. I add them up, divide by 45. If there's 45 people in the class, and that would tell me the class average on exam 1. Okay? It's not the only piece of information that's important to know about the distribution. Okay? We're also interested in the standard deviation, which is the average deviation around the mean. Okay. Here, it looks at the variability of scores. So, for example, say this is like exam 1. It's like 20%, 40, 60, 80, 100. Okay. So say, and each dot is like a score, right? Say this is how everybody does. Like each dot is an individual score on this exam. Okay? So we could have like an average. You can maybe guess that it's like around like a 65 or something. You could say it's the average. We could have a distribution like that. We can have another that has an average of 65, say, but maybe the distribution scores look different. Maybe there's more variability in it, right? So these are more clustered together right here, and these are kind of have a different shape to it, and they could have the same average, but we're missing how the scores are variable, the variability in the scores for this exam. So standard deviations, here's the mean. We're looking at the average distance from each point to the mean, right? And they all might be further away than the other. So taking all these distances from the mean and seeing what is the average. So if something has a large standard deviation, that means that in that distribution, there's more variability. Something with a lower standard deviation means that the scores are more clustered together, right? So maybe something with a low, for a class grade, maybe something with a lower standard deviation, maybe most of the scores in this class are between an 80 and 100%. Something with a larger standard deviation against the average distance from the mean, we're looking at something that might be scores between like 30% and 100%. 80%, 100% is really close together. The other one's more spread out. Okay. Here's another example. Quickly find the mean for each of these classes. Say in order to get into this class, you had to do a statistics quiz basing what your baseline knowledge is, and there were 8 questions. Okay. And this is how 3 different classes perform on this baseline measure. So find the means for each of these classes. On this one? What does it mean for class 1? 4. Class 2? 4. Class 3? 4. This is where it becomes important. We can't just look at the mean. Look how different this is. Like if this was a real life example and I had classes that looked this way, what might that tell me? If we look at the scores, the variability of scores. Like this class, they all seem to be coming in about the same page, right? They have about the same amount of knowledge. I might want to check which questions they got wrong. Maybe they got different questions wrong, or maybe it's all the same. They're kind of coming in at the same place. Here, there's some variability, but between a 3 and a 5, they're about the same with a little bit of difference. They're kind of on the same page, what you'd pretty much expect. Here, if I'm having some of my class with 8 and some of them at 0, I'm having people at very different levels in this class, and that might affect like how I instruct. I could be talking about mean, and then a third of this class are like, I already know how to do mean, let's do something else, right? But you're trying to do instruction for a wide variety of scores. So it's important to look at mean, but it's not just that. Like, what is the variability in the distribution? And that's what standard deviation gets at. And again, this just kind of talks more about what I just mentioned about the different classes. Like here we have some of the same means minus this one. We have the same means, but the shape of the distribution could look very different about how people scored. And here, like the shape can be very similar, but the mean can be different. So I just want to recap quickly like what we were talking about today before I let you guys go again. So where did we start? Was it the shape of distribution? So there's a normal distribution, and what does that mean? Like symmetrical, same on both sides. We have negatively skewed. What does that mean? Yeah, there's a trail off towards the end, so we have people scoring higher on whatever your measure is. And the opposite is true for positively skewed. So look at the shape of distribution. And then we talked about percentile rank. What is a percentile rank? Yeah, like a percentage of people who scored below a particular score. Okay. What is the formula without looking at the board?
P equals P, the number of scores below you over the total.
Right. The score is below the score of interest divided by the total, people or whatever it is that you're looking. The number of people in or number of things in your population or sample of interest times 100. And I said that percentile and percentile rank, you don't have to know it. It's just mean and standard deviation. Is that all that we covered? Yeah. Yes. All right. So those are the concepts that I want you to get the most and be able to calculate on your own. If you have any questions, let me know. We're going to be hitting Z-scores probably, but we're going to calculate standard deviations on Friday. If there's time, we'll go into Z-scores.
Oh, we haven't calculated standard deviations.
We're only getting to why that's important, but we haven't gotten into how to calculate it. Yeah, homework is not due this coming Monday. It's going to be the following Monday. And I'll send an email. It's going to be moved.